So you'll remember the quadratic equation. Hopefully you do. When x is an element of the real numbers, the solution to a quadratic that has any coefficients a, b, and c is when x is equal to minus b plus or minus the square root of what you know as a discriminant, okay, b squared minus 4ac, all divided by 2a. Now that had no real solutions when our discriminant was less than 0. But for complex numbers, that's not a problem, correct? Because we can take the square root of a negative number. So for z that is a complex number, the solution to the quadratic is exactly the same with the coefficients, just that if the discriminant is less than 0, then if you switched it around and multiplied it by -1, you can put the I out the front and you have an imaginary number that's obviously forming part of the complex number. But let's just get straight into an example for this one. All right, so we're going to solve for this. So using the equation, we're going to have z equal to minus b is minus 5 plus or minus square root of 5 squared minus 4 times a times c, all divided by 2 times a. Okay, and I'm just writing numbers straight in there. So in the square root here, we've got 25 minus 36. And of course, it's all divided by 6. So that's just minus 11. And you should know that the square root of minus 11 is the square root of 11 times I. And because we were in the habit of factoring out the denominator in front of the rest of the complex number, we can now write that as 1/6 of minus 5 plus or minus the square root of 11 times I. That really is all you need to do, okay? So all you have to do is sub it into the quadratic formula and now use the tricks you know to deal with a negative square root. But there is a note to make about this. So while this is a little bit beyond what we're doing in this unit, you've all worked with polynomials in your methods and in specialist, and you always come up against how many solutions there are to this polynomial. Or when it's written out like this, you're trying to figure out how many factors does it have. In the complex plane, it's going to have n linear factors. The only thing that sort of confuses that is that you might see, for example, z plus some constant r all squared as one factor, but really it's 2 repeated factors. And one other thing, don't be afraid to use your friend the Kaz, okay? There are lots of little notes in your textbook. It's not worth me going through it. You should just copy down the techniques or the commands that they expect. All right, so that's it for this lesson. So it should be a quick one, nice and easy. We'll see you back in class and you can tell me how easy it was or how amazing you are. Bye.